Hi, welcome to Ultipa's Graph Analytics and Algorithms class. It's our first episode of this video series, and we are going to explain three commonly mentioned concepts: graph query, graph algorithm, and graph analytics. You may have heard people mentioning them, but what exactly are they? Let's start with graph query. This is a graph query example. I want to find all movies with score greater than 4. In the graph, I have two kinds of nodes. Blue nodes are users, green nodes are movies. And we have edges named like, point from user to movie. I only want movies, so I'm gonna ignore the other nodes and edges. And if you look at the table here, some properties are created to describe the movie, and score is one of them. So this query can be easily achieved by Ultipa's graph query language, UQL. A find command is assembled with a parameter nodes. In nodes, we put filtering conditions at movie and score exceeds 4. By defining the query results as alias called movies, I return the results in the end. You see, UQL is quite easy to understand. Another graph query example. This time, I want to find movies Mark and Joe both like. We can see from the graph that movies Mark and Joe both like are movie 1 and movie 2. In fact, no matter how many movies the two users like in common, the query can be translated into this past template. In the template, the first and the end node are Mark and Joe, and they both have like edges pointing to the movie node. We could write the query based on this template. Overall, you see this statement is made up by N and E alternatively, and they are connected by dot. N means node, and E means edge. We put some description into every N and E to customize it. The 3N matches the 3 nodes in the template, and we have 2 like edges in between. And to return the movies liked by both users, we define alias in the middle movie node, so it can be returned later. From these two examples, we could extract some key points of graph query. First, when I do graph query, I basically know what I'm looking for. I have specific purpose or target. And second, graph query is usually done based on a template. Third, most of the time, graph query focuses on local graph instead of the whole graph, because when you write a graph query, you are expected to input some filtering conditions, or you should know how to form the template. Of course, queries without the detailed configuration are doable, such as I could write 5 nodes without any filtering rules in the nodes parameter. Then the system returns all the nodes in the graph database. But be careful of running such command on large datasets, which may burden the graph system. Our next topic is graph algorithm. We also prepared 2 examples. This one used the degree algorithm to find the top 2 users who have the most followers. In graph theory, degree of node refers to the number of edges connected to the node. But we need to be clear which edges should be counted. If you look at the user node Mark in the graph, there are 3 follow edges connected to him. 2 are pointing from Mark to others, and 1 is pointing to Mark from others. To calculate the followers of Mark, we should only count the edges point to Mark. The other 2 edges should be avoided. Ultipa's degree algorithm is prepackaged for you to use, so the UQL starts with command algo to call this algorithm. In the following params parameter, we could write some configurations. Here we write the direction and to specify it as in. And we define the results as alias top. After sorting the degree and the descending order, we could return the top 2, which are Anna and Joe. These 2 users have the most followers. Another example, use the hyper-ANF algorithm to calculate the average distance of the graph. Average distance is defined as the average length of the shortest path of all node pairs in the graph. To be specific, in our social network graph here, what average distance means? It means through how many people in average one user can somehow relate to any other user. And here we ignore the direction of the edge. As long as there is edge between two users, we regard them as connected. So we write the UQL here. The algorithm name is hyper-ANF. The params parameter contains two configurations. I will not explain too much about the meaning of these two items here. If you're interested, please check out the algorithm documentation on ultipa.com. Let's see the results. It's 1.68. It means that my graph is very tight. On average, every user could reach out to any other user within 2 steps. After seeing these two examples, do you have a sense about what graph algorithm is? Firstly, graph algorithm can be viewed as encapsulated functions. Some algorithms may seem easy, that you feel like you could write by yourself with graph query language. It's maybe true, but most of the algorithms are not that straightforward as it looks. And in real applications, your graph database can be huge, with millions to even billions of nodes and edges. The algorithm should be optimized in order to process massive data in real time or near real time, so that some ingenious solutions must be applied. After all, we are not talking about using single-threaded Python to process C-value big data, which takes forever. Second, automated exploration. And third, global or local focus. These two can be explained together. Some algorithms' goal is to identify some structural features of the whole graph. For example, to analyze the compactness of the graph, or to see how many communities the graph can be divided into. When using these kinds of algorithms, you're more like exploring the entire graph. You can't just see those features of the graph by your eyes, as the graph is either too big or the features are deeply embedded within the data. So that sophisticated graph algorithms we invented to help facilitate our tasks. Okay, the last concept we will cover today is graph analytics. Once your business data is well organized and projected into graph, the graph itself can tell you plenty of information. Because graph is naturally good at modeling after real-world scenarios, and particularly describing the connections of data points and allowing deep penetration and correlation of such data entities. And once you derive information smartly, you have a better knowledge of a business so that you are able to discern new business opportunities, identify pain points, solve some chronic problems, make smart and real-time decisions, and the list goes on. With the purpose of graph analytics in mind, I would say that graph query and graph algorithm are both effective ways to do graph analytics. They serve for different scenarios, and you can think that graph query is more like an entry level, a building block thing. Of course, you can write advanced and highly sophisticated queries to serve your needs, but you should also watch out for alternative solutions like graph algorithm, which tends to be convenient and lightning fast. So this is the end of our first video. Thanks for watching. I hope you enjoy, and I'll see you next time.